I'd like to acknowledge the traditional custodians of the land on which I am recording this podcast today, the Gadigal people of the Eora Nation, and recognise their continuing connection to the lands, water and culture. I pay my respects to their elders of the past, present and emerging. Hello and welcome to Unstressed. My name is Dr. Ron Ehrlich. Well, today we are going to continue our exploration of improving immune function. One of the frustrations that I have about the way we've approached this pandemic is really our lack of focus on immune function. I mean, if public health is truly the number one goal in what a government delivers to its people, then I think we should be embracing everything. And that means whatever pharmaceutical is needed to deal with if you have a bad case of COVID or a vaccine, yeah, look, I'm okay with that too. I'm not anti-vax. But if you were truly interested in public health, wouldn't you also be promoting improving immune function? Sadly, that is not the case, either here in Australia or in the United States, where they've just launched a COVID Consumer Protection Act, where any mention of immune function positively affecting COVID is deemed fake news and is being removed from Facebook and from YouTube. So I'm a little bit annoyed about this, and that's why I'm focusing on it in this podcast. And it's such a pleasure today to have my guest. My guest is Dr. Michael J. Gonzalez. He's a professor at the Nutritional Program, School of Public Health in the Medical Sciences campus at the University of Puerto Rico. He earned a bachelor degree in biology and chemistry, a master's degree in cellular biology and biophysics, and another master's degree in nutrition and public health. He then went on to do a PhD in health sciences and another PhD, as though that wasn't enough, in nutritional biochemistry and cancer biology. Now, we discuss a lot of that in today's program, and I think the point that you perhaps need to remember when you're listening to all of this is that every cell in our body goes through trillions of biochemical processes each and every day. And inside our cells, there's a thing called mitochondria, which are the power packs. And when I was in undergraduate dentistry, and when a doctor or any health practitioner does undergraduate work, they study biochemistry, which is the study of every one of those processes that drives healthy cell function and therefore healthy immune function. So what goes on at a cellular level is critically important to our health. And how those biochemical processes go is also critically important to our health. And in order for those processes to go, that's why we need vitamins and minerals. That's why deficiencies in vitamins and minerals are so important. Pharmaceutical products are not an essential nutrient. And when pharmaceutical products are introduced, or when we are exposed to toxins, our liver has to go through a detoxification process. But it doesn't have to do that when we have our nutrients. So this is a really important point, and that's why someone who is familiar with cellular biology and biophysics, who is involved in nutrition and nutritional biochemistry and cancer biochemistry is so important. Now, Michael completed also, as though that wasn't enough, Michael completed a postdoctoral fellowship and is a fellow of the American College of Nutrition. He has authored over 100 scientific publications, some of them with some of our other guests that we've had on this podcast. He's an active member on several scientific editorial boards, including the Journal of Orthomolecular Medicine, which is where I have had the honor of meeting him. I hope you enjoy this conversation I had with Professor Michael J. Gonzalez. Welcome to the show, Michael.
Thank you.
Michael, you're talking to us from Puerto Rico, which I'm really interested to hear how things are going over there. But when I looked at what you had done, on your journey, it's been quite incredible. the number of masters and PhDs. I wonder if you might share with us a little bit about your journey.
Well, it's more than a journey for degrees. It's a journey to gain knowledge. And let me tell you, it was a bad idea. And I'm going to tell you why. Because most of the things that I practiced, that I learned it on my own, not really when I was taking these degrees. Although it did help me to some extent to understand certain things, understand things that were done wrong so I could do them right. But it's not something that I really recommend. But because when I started out, when I was in high school, it started in high school that my grandfather, who I was raised up by my grandparents, and what happened was that he got a liver cancer, and there was nothing that can be done to him. So I was a kid in high school, and I went to the medical school library to see what I can find to help him. And I think, the librarian saw me and said, "Kid, what are you doing here?" I said, "I'm looking to help my grandfather who has a terminal cancer." And I think he felt sorry for me more than anything else. And he always was looking around. And one day that I came in, he said, "Hey, this journal just came in. And it has an article on vitamin C helping cancer patients." And he said, "I'm going to photocopy it for you. I'll give you 2 copies so you could take one to the physician." And I said, "Sure." And when I started reading, I said, "Oh, vitamin C, that's interesting." It was a paper by Linus Pauling, Erwin Cameron, and Brian Leibowitz. And the article, the name was Vitamin C and Cancer. And it was see if I remember the Journal of Cancer. It was the Journal of Cancer. And it was 1979 when I saw that. And I got so excited because they were helping patients with 10 grams of vitamin C, first intravenously and then orally. So I went running to the physician, and everybody said, "Hey, he's not going to pay any attention to that, So he was on a physician, at the hospital. And I brought him the article. I said, "Can we do this with my grandfather?" And he said, "I'm going to take it. I'm going to read it. And you could call me tomorrow." But actually, he knew that my grandfather was terminal. So I think he just read it. I think he was willing to experiment, The next day when I came in, he told me, come with me to the pharmacy. Let's check out this vitamin C." So we went downstairs, and they only had it in these little crystal vials, and it was 1 gram each. So we had to break these vials and put them in the IV bag, and we did that. And in the second bag that we put him, he was in a semi-comatose state, and he woke up, and he was all impressed with that. And then a couple of days, they sent Grandpa back home, but eventually he died of the cancer, because after that, I gave him some. We bought oral vitamin C, and I gave him some, but I don't think he was taking probably about, I don't know, maybe 3 or 4 grams. It was not really enough for all the condition that he had. And I didn't know as much as I know now what I had to, what to do. And he died of the cancer eventually, but we saw him get better, ask for food, get up from that semi-comatose state. And that really encouraged me to want to study all these aspects of using nutrients as therapeutics in different diseases. So it's called orthomolecular medicine, as was named by Dr. Linus Pauling and Abraham Hoffer. And so the only person that I knew that worked with Linus Pauling and was a biochemist was Jeffrey Bland. I don't know if you know about Dr. Jeffrey Bland.
I do. He's a legend in nutritional. In the world of nutritional medicine, Jeffrey Bland is a legend.
Yeah, well, he was a founder of functional medicine. And I think functional medicine is the clinical application of orthomolecular medicine. So I wrote to him. He was at the University of Connecticut. He was teaching. And I told him, I want to do a doctorate degree in orthomolecular medicine. And he told me, it doesn't exist. And then he said that I should study biochemistry. So eventually I got a PhD in nutritional biochemistry at Michigan State. So I did what he told me I should do. And it was funny because later on, it was, I think it's in the year 2017, that he was giving a conference, and I was also gonna give a conference. We were in the same conference. We were, we were gonna give conference in the same place. So I get to see him. And I said, you're not going to remember me, but I'm going to tell you who I am. And I told him, I said, yes, I remember. You wrote to me when you were in high school. You remembered. And I said, well, I have good news for you, because that was in 2017. I said, last year I was inducted to the Orthomolecular Medicine Hall of the Fame. I said, so you made it.
Fantastic. I mean, he is a legend. The first time I heard of Jeffrey Bland, I did his course through the International College of Nutrition in Australia in 1981. So I've heard of it, but it's interesting, Michael, you've done all these courses, you've done all these degrees, and you say most of what you've learned outside of these formal education. That is so interesting.
It is. Actually, you know, the thing is, the advantage that I have to a certain extent is that I have experience in the lab, I have experience with patients, and I have experience teaching. So I seen all these things. I seen how it works in animals, how it works in cells, and how it works in human beings. And everything is a little bit different when you go through all these different ways of looking into research. But there's some commonality, but there's a lot of differences also. And you have to really be open-minded to understand this. Sometimes scientists are so focused that they miss. It's like they want to understand the whole environment, but they're only looking at the leaf. And you have to look to understand it ecologically. You have to look at the whole system. And sometimes you lose that when you focus that much. But it has to be like a balance between focusing on some things and looking at the whole picture in another way. So that's what I have really learned on my own, that I have to be cognizant that there are many variables, there are many things that interfere, and that I have to have a general whole picture of what's going on. Well, and that has helped me with patients.
Yeah, what a unique position to be a researcher, clinician, and teacher all wrapped up in one. So, but you're in Puerto Rico, and Puerto Rico is an island like Australia. I mean, admittedly, Australia is a bit bigger than Puerto Rico, but you've got about 3.5 million people there. How has this, before we dive into some of your research, I'm just intrigued to know how things are going over there in terms of the COVID response as an island.
Well, let me tell you, we're influenced too much by the United States, which is not good because, everybody talks about CDC, but CDC has managed it horribly, this viral infection. So it has not been too effective in managing it. And I think with this issue with the vaccines are that they advance so much to try to make them use for public use, that I think we don't really understand what's going on. And I don't think they really have a good grip in terms of how the immune system works. I mean, the immune system is a check and balances kind of system. It's very complicated and it's very individual. Everybody has their own immune. I mean, there's some generalities, but there are a lot of differences also. And I don't think they have really stressed much in these differences and stretched much in how important it is to have a optimal immune system. People talk about enhancing the immune system, but it's not really enhancing, it's optimizing it. Because if you enhance it too much, you're going to have an unbalanced immune system, and you don't want that. You want a very balanced, very rapid response immune system. And that's the only way of doing that, is understanding its complexity and understanding that it entails many enzymes, many metabolic pathways. So you're going to need a lot of cofactors. And that's where all these nutrients come in: vitamin C, zinc, vitamin D. And you're going to need these nutrients in order to balance that immune system and to have it work optimally, which is efficiently and fast. So, it's right now what we're saying here in Puerto Rico is don't try to limit your sugar intake, limit all the products that are not natural, all these because actually sugar, it's the main enemy because it competes with vitamin C. And then your first defense against viruses and bacteria is your T cells. And the T cells have receptors for sugar and vitamin C. But if you compete with vitamin C, you're not gonna have enough formation of peroxides that you need in these lysosomes in order it to fight the virus and the bacteria. So you're going to unbalance your immune system. You're going to have a less cellular response, which is your first response. So your the viral the viral load is going to be more, and then your secondary immune system, which are the antibodies and the cytokines, are going to increase up, and then you have a cytokine storm because of too much viral load, because your primary cellular immune system is not responding well. So all these things can be corrected when you have enough of the vitamin C, which is probably the nutrient that has more antiviral mechanisms. Vitamin D has a lot of antiviral mechanisms, although they're secondary. And zinc, which mainly zinc helps a lot because it inhibits reverse transcriptase. But in order to do that, you need a molecule that will get zinc into the cell. And that's how they were using hydroxychloroquine, which could probably do that. But there's something even more simple and less toxic, which is quercetin, that could do that also. So we're looking into that. You know, we're promoting a diet high in vegetables, fruits, low in sugar and carbohydrates, and processed foods in general. And the intake of multivitamin and mineral, probably a high dose one, vitamin C, at least 3 grams, 1 gram 3 times a day. Vitamin D, at least 10,000 units. Zinc, at least 30 milligrams. And magnesium, because sometimes people have enough vitamin D, but it doesn't work well if there's no magnesium there. So you see all these synergistic effects of the nutrients, although you're going to have to use some of them in a little bit larger doses during this pandemic period in order to make a physiological difference. And been a lot of problems with the physicians, because some of this, oh, but vitamin C is water soluble, you take it and you drop it. But they're forgetting that even if that's true, don't drink water, because you drink water and then you pee it.
Yeah,
but the point is that in the interim, you have a lot of physiological effects. Water will decrease your temperature, will help nutrients get to the different cells, will help the detoxification process of getting the detox out by the urine. Also, you have a bunch of effects, of physiological effects that goes on even when you drink it. Just the matter of going through, it's going to have a lot of physiological effects. The same thing happens with vitamin C. Although vitamin C, you're not going to eliminate all of them. You eliminate some of it, but you produce collagen with it. You're gonna you even produce energy with it, because it's a excellent reduction molecule. So we have seen that vitamin C increases energy by you being like an electron promoter of the electron transport system. So if you have all the rest of the things, CoQ10, the carnitines, the B complex, it's going to help push that electron to the electron transfer system. And that's what really produces energy. We would not have life on Earth without vitamin C, because all that electron movement of photosynthesis, it's because of that ascorbic acid molecule.
Wow, that's just such a great description of my next question, which was how does that look like in practice? And you've just mentioned all of these nutrients and the levels at which they are. You're also a professor of public health. And one thing that really, maybe I'm naive here, but I would think that in public health, we should embrace everything that could improve public health. So that might include embracing pharmaceutical alternatives like vaccines. I don't think that's a bad thing, but I'm just, in Australia, whenever we mention anything about immune function, it's almost heresy. In America, I believe you now have the COVID Consumer Protection Act. We spoke to Dr. Richard Cheng earlier this week, and he informed me that there's a consumer protection to protect people about any mention, more or less, about immune function. What is going on? Why shouldn't we embrace all these things?
That's the power of big pharma. They just want to sell.
That is the reality. Is that the reality, Michael? Is that the reality?
Oh, yeah, definitely. But the thing is that it could be done in a more effective way. I mean, I'm not against vaccines in general. I'm just against that there's not enough science to really push these vaccines as they have been pushed. And I think it's blowing on their face right now with all these adverse effects about the coagulation problems, about the damages to the alveoli, damages to the vascular system, damage to hemoglobin. Actually, we're just finishing a paper talking about vitamin C, how vitamin C can prevent all these pathophysiological effects that that the cytokine storm can produce, especially damages to the vascular system, to the platelets, to the hemoglobin, and to the alveoli.
Now you've done a lot of research, you've written a lot of papers about, now cancer is another area I know you're very interested in. And while we're on the topic of vitamin C, I know there's this controversy about whether vitamin C and its effect on conventional cancer therapies. I know you've written about this. What's your view? Can you share some of your thoughts on this issue?
Well, first thing is that vitamin C, it's not, physicians in general, especially oncologists, have no idea how vitamin C can work. They just think it's just a vitamin, how a vitamin could be anti-carcinogenic. And I think one of the most important people, I mean, you could mention Linus Pauling, you could mention Dr. Huey Reardon, who was my mentor. But you know, one of the most important guys here, I think it's Mark Levine from the National Institute of Health, because Dr. Mark Levine had really shown the increase in nitrogen peroxide as a mechanism of inhibiting cancer cell growth. And basically, I think it's a perception. A lot of physicians want to use vitamin C as a pharmaceutical agent. And you can be using it in pharmaceutical doses, but pharmaceutical doses of vitamin C are very high doses. And they're forgetting that the body can manage nutrients in a different way as pharmaceuticals. Pharmaceuticals sometimes need to be activated by these detoxins in phase 1, phase 2, and nutrients don't work that way. Nutrients, just the body, are physiologically friendly molecules that the body knows how to use, and the body doesn't even use energy to eliminate them, just eliminates them in a process when they're in excess in the body. So it's a different pharmacodynamic and pharmacokinetic form of looking nutrients versus drugs. Physicians don't understand that, and that's many of the mistakes that they do when they're doing these experiments, because they use very small doses that are not going to have the same effect as the large doses do, but because they're scared of using large doses, because they think it behaves like a pharmaceutical agent, and it does not.
Because I get the feeling that whenever we look at recommended daily intake of these nutrients, what we're talking about when we look at the official line is enough nutrient to avoid identifiable disease. So the nutrient, I think the dose for a daily dose of vitamin C, you would know this better than I. What's the recommended daily intake of vitamin C?
Well, it used to be 60. I think now it's 90.
90 milligrams. 90
Which
milligrams.
is nothing. It's nada. No.
Yeah. I mean, that will stop us getting scurvy.
Yeah. But that's a terminal disease.
That's it?
That's a terminal disease. You could die of scurvy.
Yeah. Yeah.
So,
yeah.
I mean, you know, the dose for optimization may be different from person to person, but it's definitely more than 90 milligrams.
Yeah. And what would that range be? Say from a healthy individual, an individual with comorbidities, and an individual with cancer, just roughly so people can get their head around dosages.
Well, this is my personal opinion. I think it would be between 500 milligrams and probably 3 grams.
Yeah, for a daily dose for a healthy person.
Yeah, that's what I think will be a good maintenance dose for maintain a healthy state. And
if someone was you mentioned in cancer therapy that those doses could get really high. What is sort of the range of doses that are used within cancer therapy?
Well, my friend Steve Hickey is going to kill me, but because he advocates a lot the oral dosing, and I think he has a point. I think oral dosing, because I use a lot of IV, because I think IV you could reach higher levels quicker and sustain them a little bit more than you do with oral, because then you have that limit of absorption and stuff. But he has a model which he calls the dynamic flow, in which he gives certain amount of vitamin C like every hour in order to keep the levels high in blood and in circulation. But it's very unpractical sometimes because you have to be 24 hours taking 3 grams every hour. It's a pain, you know.
Yeah.
So, but I think it might be possible. If Hickey says it, he's probably correct. But the thing is, it's not practical. Yeah. So what we use one-time dose of IV vitamin C, and once we do a G6PD test, we may start with 15 grams and go up to 25 and go up to 50 and even 75 grams. And we keep it between 50 and 75 because we want to prevent recycling of ascorbic acid, because we want ascorbic acid that in the presence of oxygen produce hydrogen peroxide. But if we give too much vitamin C, that's going to be inhibited and it's going to recycle back to vitamin C, and you're going to have less production of hydrogen peroxide. So you're going to have a less anti-carcinogenic effect. So that's why it's kind of a wicky-wacky, dose. We have to really be paying attention not to inhibit what we really want to increase in cancer patients.
Now, you mentioned hydrogen peroxide, and I had the pleasure of talking with Thomas Levy a few months ago on the subject of hydrogen peroxide, and it was quite surprising how ubiquitous it is in our bodies and how important a role it plays. Can you just tell us a little bit more about, you mentioned it twice there, hydrogen peroxide, and Thomas has mentioned it as a nebulizer. Tell us a little bit about hydrogen peroxide.
Well, Tom is probably the person to ask, but
I have asked him, but it's a good revision. It's a good revision.
Yeah, well, actually, I'm a very good friend of Tom, and we were inducted the same year to the Orthomolecular Medicine Hall of Fame. And Tom is a very knowledgeable guy in this area. But what I can tell you is that it has a biphasic effect. In very low doses, it's kind of like a signal molecule in the body. But when you go to high doses, it may have physiological pharmacological effects. The thing is that the body manages it pretty well because most of the normal cells have catalase, superoxidase dismutase, glutathione peroxidase, and then the body can manage it very well. And the point is, that's one of the things he said, if you get the virus, use it as a nebulizer and you're going to be okay. So that's one of the directions that Tom Levy does in terms of this virus. But it helps even clear the sinuses and all that stuff. I have occasionally done it, and it feels, you have to watch out because if you use too much, it might be irritating. But if you use the right dose, it's a good sense of clearing your respiratory tract.
Yeah. Now, I wanted to ask about cancer because it's such a big issue. It's often referred to as a genetic disease, but some of your research, and I've also had the pleasure of speaking to Thomas Zayfried about this as well. But I wondered if you might share with us the difference between the view that it's a genetic disease and the emerging view that it's a metabolic disease.
Yeah, well, let me tell you, Tom is a great guy. But let me tell you a story. I came out with a paper, which is I would call it it's a theoretical paper, which I call it the bioenergetic theory of carcinogenesis.
Say that again, Michael.
Yeah, the bioenergetic theory of carcinogenesis.
Bioenergetic.
So that was my idea of cancer as a metabolic disease. It came out, I think it was 2014 or 2009. I don't remember well. But the point is, I didn't know about Thomas Zayfried. And after I wrote that paper, I learned about him. And he never know about me. So he came to his ideas by his own, and I came to my idea by my own. And after that, we met and we wrote a paper together, which is called Mitochondrial Correction, which is, I call it that Avenger group up. And you know that Avengers, all these superheroes that in these Marvel movies.
Yep.
And that paper, I have Thomas Zayfried there. I have Dominique D'Agostino. I have Garth Nicholson. And I have another group of superheroes in the science field. So I call it the Avenger paper. But Garth Nicholson is the guy who developed the model of the membrane, the fluid mosaic model of the cell membrane. So he has been nominated for the Nobel Prize. and for that. And Thomas, you know, Thomas is the leading person in talking about cancer as a metabolic disease. I'm the junior, he's older than me.
That's all right, but the junior often gives us a more down-to-earth explanation.
Oh no, he's excellent. He's excellent.
Yep.
Actually, I saw some things that he didn't see, and he saw other things that I didn't see, and we complement each other very much in that sense. But let me tell you one thing: when something doesn't make sense to me, I call Thomas Seifert, and he kind of figures it out. So
Right.
That's why I consider I'm his junior.
Yeah, but give it to us 101. Tell us what the genetic view of cancer is, and then remind us, because, you know, I think this is an important issue.
One point that that we had figured out, it's that the mitochondria is not working normally in cancer patients. And that what it makes, it's that you cannot produce mitochondrial energy. What you produce, it's mainly by glycolysis, and that has been observed. It's called the Warburg effect.
Yep.
And the point with this is that's why the cancer cells use glucose so much, and it's their main source of nutrient. It's of macronutrients. It's glucose. It's sugar, and they use it as a PET scan. The PET scan, it's looking how much sugar that malignant tissue it's taking. It tells you how, you know, it gives you an idea how bad it's going to get. But the thing here is that it's basically that the mitochondria is not working. If your mitochondria is working, you have a lot of energy. Energy helps with the order, organization, and compartmentalization of things. So it kind of organizes you. Energy has that power of organizing you. And the thing is, differentiation requires multiple steps, multiple physiological steps, and it requires multiple nutrients and multiple enzymes. And the only way of doing that is when you have enough energy to produce that, to maintain the order and the organization. So it's kind of an unbalanced, wacky sense. This using sugar, it's a survival mechanism. It's an old mechanism that the cell has that uses it, but it's the only thing that can do to survive. Once they do that, they lose communication, because you don't have energy for communication. So it's every cell on its own. That's why they start dividing to try to survive. But there's no connection. There's no communication between the different cells and the different tissues. And that's why it overgrows and produces the tumor.
So you mentioned the word differentiation, and by that this is about liver cells forming as liver cells and pancreatic cells forming as pancreatic cells. And this is what you mean by differentiation, yes?
Yeah. Well, with differentiation, when you look at the cancer cell, it looks like an embryonic cell. It has lost its characteristic of the tissue where it is. It keeps some of them. That's why you identify it, but it doesn't keep all of them. And the thing is, it loses that communication capacity. That's what we call that. It loses its differentiation. And the point here is that once this happens, you first have this metabolic derangement, but it's followed by a genetic change. So you have genetic change. People call it mutations, and I think it's more an epigenetic effect than a mutation effect. Mm-hmm. Although in certain occasions you may have mutations leading to cancer. I mean, there's no question about it. And there is a genetic component even in the presence of this metabolic derangement, because what happens is, once you have this change in metabolism, the body, it's gonna, turn on genes needed for that. So you have a genetic change after the metabolic derangement.
Mm-hmm. Yes, so it's not all or none. It's not he's right, she's right. This is a combination, piecing this all together. The thing that surprises me, and again, this is back to our question about public health, is that the medical profession is readily accepting of the PET scan as the gold standard for detecting cancers, and yet making that mental leap into how sugar feeds, or carbohydrates feed cancer, never seems to be made.
Yeah, well, yeah, I mean, You know, I had this discussion with Dr. Pauling, and I said, you know, physicians sometimes are not trained. They're trained to work fast. They're not trained to think. And I don't want to say that they cannot think, but you know, sometimes conventional medicine, it's very effective in acute problems, but in chronic degenerative problems, it's not, because sometimes they just want one pill, one solution, and it doesn't work that way. It's a lot more complicated than that. But the other issue there is that I don't know how they cannot make that jump. Let me tell you, there's a story that I was in an interview. In the previous interview, I said about the sugar being the main fuel for cancer cells, and the physician said that I was wrong, that all cells use sugar, that I was saying that I didn't know what I was talking about and all that stuff. I said, okay, so I don't know what I'm talking about. Say, yeah, you don't know what you're talking about. Okay, fine. One question: when you have a tumor, what type of test you use? Oh, we use markers. No. If you want to see it growing, so we use a PET scan, he said. And when he mentioned PET scan, he then went quiet. What the PET scan uses? He said glucose. Oh, I rest my case.
Yeah. Yes, it's incredible. And actually, you know, you made that point about T cells, that sugar, the receptors compete with the vitamin C there. And of course, it's not just sugar, it's because it doesn't take long for carbohydrates to be broken down to sugar.
Yeah, it's an unfair competition to really run, because when we eat carbohydrates or sugar, we eat them in grams. Yes. And when we take vitamin C, we take milligrams. So it's an unfair competition.
So my question is, and this is another thing that people hear, and I asked you about doses, and you said 500 milligrams to 3 grams a day for vitamin C.
You're being conservative. Let me tell you.
You were being conservative.
I'm being conservative.
I know that. But that's okay. That's something people can get their head around. Another thing people hear about is low carb. And it means so many different things to different people. What does low carb mean to you?
For me, it means low, simple, refined carbohydrates.
I know, but if you were measuring your carbohydrate intake in grams a day, what would be a low carb diet? Because, you know, when I went on to the USDA site and put in all my parameters for a health practitioner, you know, this is advice. According to the USDA, I should be on between 350 and 475 grams of carbohydrate a day.
Yeah. We think that's a bit. It depends the source, really. If it's complex carbohydrate, if you don't have any cancer or any degenerative disease, you might be on the safe side. If you have cancer, it might be too high. You should probably go lower, 200 or lower. Mm-hmm. Okay. Keto diets use 50 grams or lower. So, and the problem here is also, Ron, that even when you go in these very low carb diets, the body starts producing these ketone bodies, which it's good, especially in cancer and any degenerative disease. It has a beneficial effect. But the problem is that after a certain time in these diets, you started using glutamine as a source of energy, and that has confused many scientists, thinking that you have oxidative metabolism, thinking that the mitochondria is working when it's not, but it's using glutamine as a source. So it's working in that way. And the problem with that is that's why the differences between the keto diet and the other low carb diets that came before, because the other low carb did not restrict proteins. And you have to restrict, you need enough proteins to have your immune system working well, but not enough protein to feed that glutamine shuttle to produce energy. So, and that's something that Thomas Seyfried made me aware of. It was not, it was his research that made me aware of that. And so we don't really know. I mean, if you have to cycle this ketogenic diet in cancer patients, I think Miriam Kellerman, who wrote a book on keto and cancer, which she had her son extend his life with using the keto diet. He had a very terminal brain cancer. and she did the keto. She experimented the keto diet with her son, and he really, went a lot over the what was expected for him to survive. And she has really looked into all these aspects of it, and she's a very close friend with Thomas Seyfried and with Dom D'Agostino. I don't know if you know Dominique D'Agostino.
I should have mentioned I've also interviewed Dom on this show as well.
Dom is a great guy. I mean, and he's a real expert on hyperbaric oxygen and keto diet, and that combination is fabulous.
Yeah.
And if you add vitamin C, you almost have the puzzle solved.
Right. But you would say you need to be careful with not overloading on protein as well.
Definitely. Yeah, that's something.
But where does that leave the carnivore diet? How do you view that? Make a comment about the carnivore diet from that perspective.
I don't have much experience with it. I don't think we should be in a carnivore diet because it's simple for me. When you look at our denture, we have these molars. We have more molars than how you call these teeth?
Incisors. Incisors.
We have more molars than incisors. So, but we have incisors, so we have to eat certain meat. But we have more molars, so we should eat more vegetables. I think that's in terms of evolutionary, because when you see tigers, they have these incisors are very big and they don't have no molars. When you see the cows that they just eat herbs and plants, they have a lot of molars and they don't have any incisors. So you see, in terms of that, I would say that we have to combine our diet.
Yeah,
I'm a paleo man. I like the paleo diet.
Yeah, me too. Me too. I think it makes sense. The paleo diet. I mean, it's not exactly radical.
I should mention, Ron, is the intestine. The intestines, they're very long in these animals that eat only herbs and plants, and it's very short in the carnivore ones, like the tigers and lions. In ours, it's midway. Yeah. It's not as short as the carnivore, but it's not as long as the herbivores. So in that sense, that's why I believe that we should eat a mixed diet.
Yeah. So where does that? I'm just interested to hear about your view of raw vegan.
Well, I think some people do it because of religious purposes or some things, and I respect that. Yeah. They just have to make sure they have enough of the protein, and they could get it from peas and different type of beans and stuff. I think it's possible. I don't think it's a problem, but they have to be aware of that. Some people may have problems then, getting CoQ10, getting B12, getting iron, and they have to be careful with that. But other than that, it should be okay. The other thing that I wanted to mention is that there's a big argument sometimes against meat. And I think the problem is the quantity and type, because we should eat of protein. We should eat what probably is our hand, this part, maybe 2 times a day. And that should be enough to cover our real necessities. Although if you're an athlete or you are, you need more muscle or stuff like that, you may eat more. But the thing here is that the other thing is that's talking about quantity, but talking about the type, most of the meat, it's given hormones, it's given antibiotics, and that's why we should eat meat that comes from grass-fed animals, and organic, the better. And then we eat small quantities of meat, organic, grass-fed, we should not have any problems, I think. Yeah. I mean, nobody really knows because those experiments have not been done. But most of the issues have been because people eating too much meat of the wrong form. This meat full of hormones and antibiotics and who knows what.
Music to my ears, Michael, because we've done many programs on regenerative agriculture as an important environmental and health one. But another question I wanted to ask you, this is great. I've got an opportunity to ask a professor of nutrition, throw out these questions to you. What about fasting, intermittent fasting or fasting?
I'm a fan of intermittent fasting, let me tell you.
Why?
I'm reaching 60 and I started to feel a lack of energy in my body. I mean, I have all these pains in my knees and my back, and I have alleviated that a little bit, but not as much as I would like. But let me tell you, in terms of energy, I have recovered the energy when I was 30. I have all the energy in the world. And it started like probably about in my second month of intermittent fasting, and I do it almost every day. Well, I could say I could do it every day, but I try to do the 16 hours. Today I didn't do I went 12 today, but usually I go 16.
Mm-hmm.
And let me tell you, for me, I have lost some weight. It has not been a big issue. Weight was not a big issue in me, but the energy was. And let me tell you one thing, I have recovered my energy fully. And even, I keep taking all my supplements and stuff, but I took them before. I didn't have the energy that I have with this mitochondrial renovation intermittent fasting. I have become a fan of it, let me tell you. What I do is I make it easy. I eat at night, whatever time it is, and I count 16 hours after that for breakfast. Breakfast could be at 12 noon, or breakfast could be at 4 p.m. depending on what time I ate. But I wake up and I take 8 ounces or sometimes 12 or 16 of lemon water. I get half a lemon, I squeeze it, and sometimes I add like 1 milliliter of apple cider vinegar.
Mm-hmm.
That's what I take in the first thing in the morning, and then eventually I take a hibiscus tea, no sugar, just hibiscus, and then I take a green tea, and then I break my fast usually with bone broth.
Mm-hmm.
And then I eat something solid. Sometimes I don't eat anything solid. I just take another green drink, mix of green vegetables, and I keep going. And then I eat something at night. But I'm committing a problem. I'm committing a mistake here, because I'm eating sometimes too late at night, and that's not good. I should eat earlier. Even if I have to eat 2 times, I should eat earlier.
Yeah.
But I'm eating too late at night. But other than that, let me tell you, it has not affected my energy at all. Energy has been full. And I really appreciate it. The problem is that sometimes my knee hurts and I have all the energy to want to play basketball, but my knee doesn't let me.
Okay. Why do you think fasting's so good? What's going on there? Why are we just eating too much? Is that the problem?
Let me tell you. I think that one of the main issues with the fasting is that you give your body a break. It's like the cleaning. The mitochondria does the cleaning when you're not eating. It cleans up. It restores itself. And I think that's very important, that you give that time for restoration and rest to the digestive and to the energy system. And I think it has worked wonderfully for me. Too bad I hadn't really measured anything, but other than my feeding of energy, I haven't measured anything. I just started it. I just started doing it because it made sense to me, that give that break to the mitochondria and to the digestive system. And it has worked very well for me.
Well, Michael, to hear that coming from a professor of public health and nutrition, it's been terrific to connect with you and get these snapshots of information and your view on it. Thank you so much for joining us today.
No, it's been a pleasure, Ron.
Thank you.
Goodbye to everybody down under.
I thought I always enjoy talking to my guests. You probably gathered that. And as I've often said, every week I get to ask people questions about things that they know so much more than I do, and they answer them, and I learn, and I hope you do too. There was some things there that Michael said that I wanted to just mention again. He mentioned in passing T cells, which are a really important part of our immune system, and made the point that receptors on those T cells will accept sugar or vitamin C, and they'll compete. So if you have too much sugar, then the vitamin C doesn't attach to those T cells and aren't as effective as they should be. And as he said, it's unfair because we consume so much more sugar than we do vitamin C. And also the point that the recommended daily intake of vitamin C is something like 50 to 90 milligrams. And that is barely enough for us to avoid scurvy. And if that's a measure of success, then I think we could be doing much better, considering we are exposed to many toxins and a lot of sugar and carbohydrates. So I thought that was really important. And you will have heard the point about cytokine storms. And you'll also know, you will know if you're a regular listener, that the common denominator in all diseases, be they mental, physical diseases, is chronic inflammation.
chronic inflammation is the common denominator. And what happens in the body when there is chronic inflammation? Chemicals are formed, and one of those chemicals are cytokines, and that's why you will have heard the word cytokine storm so often, and why that is part of an oxidative stress, which starts to disrupt the normal function of a cell. And that's why antioxidants are so important. And if this is a theme we keep coming back to, I really don't apologize for that, because it's a theme I need to be constantly reminded of, and I'm sure you do too. Look, it was terrific to talk to Michael, and he's going to share with me some of the research papers. So if you're interested in that, we'll have them attached to our show notes. Stay tuned. Don't forget to download our Unstressed with Dr. Ron Ehrlich app. We're going to have some great resources becoming available in the second half of this year. And I think it's an important topic, improving immune function for this pandemic and future pandemics, which will inevitably come. I hope this finds you well. Until next time, this is Dr. Ron Ehrlich.
This podcast provides general information and discussion about medicine, health, and related subjects. The content is not intended and should not be construed as medical advice or as a substitute for care by a qualified medical practitioner. If you or any other person has a medical concern, he or she should consult with an appropriately qualified medical practitioner. Guests who speak in this podcast express their own opinions, experiences, and conclusions.